Hey guys, how's everything going? Today is another weekly contest. I think there will be only 4 or 5 chances before I get the interview from Facebook. So let's start. So last time I did accomplish 2 of 4 questions. Hope I can do more this time. Okay, let's jump into the destination city. Wow, 5400. We're given an array paths where paths means city A to city B. There is a direct path means yeah. Okay. Return the destination city. That is the city without any path outgoing to another city. It is guaranteed that the graph of paths forms a line without any loop. Therefore, there will be exactly one destination city. Like for this, there is a direct path from London to New York, and then New York to Lima, and Lima to Sao Paulo. Where is it? I don't know. And then we return Sao Paulo. Starting London, we will reach okay. Example this BC, B to C, and then D to B, and a C to A. Of course, D, B, C, A, right? Yeah, so this A. Clearly AZ. Of course, that's this C, Z. Well, seems not that difficult. We're given paths will be no more than there will always be one path, not over 100. This was be always valid input. City this will be what's this? The list will be small within 10. There will be no loops. Is there only one? Well, I think this example is the typical, the classic one. Let's jump right into this one. First, when we get BC, we means we can go from B to C, and then we meet DB. So DB we're guaranteed that the path forms a line without any loop. A line. Yeah. So we met DB. DB must be. Is this in order? I think there. It is not sure that it is not assumed. You should not assume that they are in order. Uh, so when we get BC, we say for B, we can go to C, right? And for DB, okay, D, we could go to B. And it got C, it got to A. So how can we determine which is the starting point? Which is the starting point? Let's see. Maybe there is another kind of input like d.f and c go to a, and we got f to b, right? Maybe we could just collect as we can, right? I mean, when we get bc, well, we just b and c. We say start at b, end at c, and then we get df. Well, it's not connected, so we say this might also be a start at d with f, but there's a to start and to end. And now we get ca. We search for all the starting point or ending point and find it, so it will become c and a, and remove it, d, f, and then we get f and b. So we search for the ending point of this 2 and find it, so we update it to b. And again, after we're doing this, what do we get? We get a b and a, and d and b, right? And then we could do this again, and it will finally get d, b, a, and so we should return a. Well, so the problem is the solution becomes clear to us. It means allow me to set the font size. Wow, I cannot set the font size. Sorry. Okay. Means collapse as we could, and until there is only one pass. By collapse, we need to. How can we collapse? As we did in example, we need to keep track. Use a what? Use a map, right? Use a map to keep track. Use a map to keep track of the heads and tails to collapse. Right, for B, C, we keep track of the head, and then the head is B, it is C, and D, F, the head might be D, so there's a user map to keep track of that, and F to do that, and when we met a new one, it might be concatenating to the head or to the bottom. So yeah, we use 2 maps. Cool. So because we do it over and over again, while there is paths, we create head maps equals new map, tail map, new map for each path. So the head, it might be the tail might be some of the existing heads, right? So there's need to be a flag. Need to be a flag. Let is connected, false. So now if head map has its tail, The map will store its head, and then this is the path. Okay, so if the head has its tail, then we need to update the path, right? So head map get tail. Oh no, we need to set a new one. Right, so okay, its path would be head map get tail, and path 0 means the start actually is equals to the head, and the head map was a delete, I think, remove. Oh, I forgot. I'll just use delete. Okay, head which is the delete head, delete tail, right? Remove the previous one, remove it, and set a new one. Set head path. We're actually modifying the input. Is that okay? Yeah, I think it's okay. If not, we're just creating a new path. It doesn't matter that much. And of course, we say is connected equals true. And then we do the same to the head, right? If the tail map has its head, we get tail map get the head. And the path, by this we need to update the second, the tail, right? So we will set it to tail. Tail is from here. And then tail map what delete the head, and the tail map was set the original head, the head doesn't change in this path. So path 0, this is still the head, and have a new tail of this path. It's connected, it's true. So if this is a standalone, if there is not, it is not connected, then what do we do? Oh, sure, we just push them both into the head map, right? Okay, head map push head path tail map push tail path. So, and then we need to remove the path, right? So we should not use for loop. We need to use we should use while loop. Yeah, remove the head map and the tail map down. So this not like this. While length. I'll just get the first one. Well, the better way I think it should be let path. While path equals to no. If there is path, it means shift. Okay. And when this while loop is done, I think there will be, because we're guaranteed that there will be only one line, so there will be only one thing in a tail map. Yeah, so we could just get the tail. But how could we get that tail? The only key, right? The tail. So return. How can I get the keys of a map? Oh, I forgot. But there should be some method. I'll try in the console. A equals new map keys. It's an iterator. So array from a dot keys. Empty, right? Okay, array from tail map keys, and the first one is the target, the end one, right? Or this costs another extra time. We could actually, when collapsing, it would be actually the end. In this case, the end doesn't change. We only change the path, which only change the ending, the destination for this case, and for this case. So every time we push one or update one, we could just update the destination, right? So let destination, we could just return the destination, and we set the path here, tail, and we say destination is tail. This should not, this is right. But actually this also changed the tail. Who is first? Anyway, I'll update it to, this one would be, destination would be tail. This also be tail. And this, in this case, we just appending a new array to the previous one, so the tail doesn't change destination. Oh, okay, let's try run the code. Runtime error. Push is not. Where is the push? God, we should set. Your answer, San Paulo. Not available during contest. Ah. Let's try custom test cases. Path like this. Run the code. We get A. Oh, cool. If we get a Z. Wow! Maybe I can finally get the bug free with one pass. Let's try submit. Ah, shit. Oh. No, it's wrong answer. Why? For this one? Okay. I don't know what it is. Let's try copy the code here. For cases like this. Oh, God. G. So these two. This. O, Q. O, Q is here. So O. Let's try do what we did in this solution. Wow. And then we met this one, so nothing happens. And this I exists, so we set it to this. O, Q. So we update this. and then I know what happens. I know what happens. We failed because we use this while loop. We need to do it over and over again. Right? So for these, we need to still, when we push the new head, push the new path here, we need to push this path back into the path because it is not processed yet. These two collapse, but this one doesn't. Okay, let's try the run the. We should return WRP. WRP. Remember that. Run the code. Judging. TLE. Oh shit. If it's not connected, it will push to the path. No. We, God, we need to actually handle the head map and the tail map. Hmm? No. Oh, we should do it. We have a tail head map and tail map. But actually we need to do it over again, which means the head map is actually wait, the relationship should be we use two maps. These two maps actually has the same paths. So I know now. Okay, actually I made a mistake. Actually, it should be while there is. Oh, while we do this. While we do this. Actually, we need to update the paths, not the map. The map is just for the collapsing, so it should be while path.length is bigger than 1, which means while until they are merged into 1, we need to do something like this. This is the destination. While there is paths, and we pass shift it, and we will push the new path back into the path, right? But here's a problem. We should end when each path in each round, right? So we add a new end identifier, which means push null. So this will end at that one pass, and then so for this new one, it will be empty generally because all is shifted. Now we set this one, so we need to push the path back again. Push path. Also here we use push pass. If it is not connected, sure, we push the path. And let's review this again. For these two, because it's not empty, we create a new map and add a new one at the end. And this while loop will process all the paths, and we check the head map if there is something there. So if we find something, we will push the new path in. If not, we just push the path in it. So we're expecting at least one merger happens, right? Let's run the code. Seems like TLE. Uh-oh. I pass, so allow me to lock the path. It will be like this. What is this? In the first round, we are getting something like this. Wait a minute. Okay, JQCR, and then we met this too. So we update J, update this one, and I find this IH, so J. So in the first round, we are left with this kind of path. Only these two, and in the last round, we merge them into one. But actually the log we get is we are getting this to 00 JMU. Where's JMU? This. JMU go to IH. The IH goes to JMG W, and this actually goes to II this, and I go to 00. So the merge actually works, but then we get 00 to W this, and then get the again. We pushed too many paths. After merge, actually the path is already in the paths array, so we don't need to push it. We only push the newly one, right? Cool. Let's try run for another time. Cool. It seems that this time it works. I'll remove the console log. Run it again. It's working. Submit. What? What happened? Ah. Ah, God, we don't need to do this anymore. The destination. At last, the path will be only left with 1. So I just return path 0, 1. Oh, shit. Time limit exceeded. Oh, God. So, is there any better way to do it? Oh, wait a minute. I think we could just oh, it just occurs to me that we could just like, rather than we keep double maps to do the collapsing, we could just pick up any one element and go to the other element to see if they can be merged, right? This one actually must be merged, able to be merged, because we are guaranteed that they will form a line. Oh shit, my bad. Actually, we don't need to do this complexity. We just could do it simply as oh my god. Let the head, every time we pick the head, while head, no, while path.length equals bigger than 1, we get the head, and merge it to the following, to the rest, merge it to the rest path. So for let I equals 2, a 1, I smaller than path dot plus plus. If head 0 equals to pass I 1, break pass I 1 set to head 1. If head 1 equals to its head, then we update the head to its head. and when we found it, we break and go and check the next one. No, actually we can do better. Oh yeah, we can do better. It's like we could set them all, transform them all to maps, and then because there will be only one line without any loop, so we can just use direct access, but we don't know. Oh yeah, direct access. Say we for each element, and we will merge them one by one. Right? Anyway, let's try run this solution. Is this right? This is very slow, I think. Time limit exceeded. Why? Oh, we need to pop it. My bad. So hit God. I want to give up. The answer is, it seems that it's not right. It should be this. When we pop, we should start with 0. Cool. Submit. Oh, finally, we're accepted. Finally, we used half an hour to do this one. What's the time and space complexity? This one will be, the while loop here will be linear, and the for loop here linear. So n to the squares. This is the time. We actually could use a map. Let's try another method. While we are in a contest, I want to try another method. Is that we can just transform this into a map, direct map, and like this, right? A BC, DBCA, and then we pick the first one. There are two possibilities, like it is the head, or it is a tail, or not the tail. If it is not a tail, we could just get the axis C and to the end, and we can get the tail. If it is tail itself, how can we tell? Is that there is nothing, when it ends, it's the tail. So we could use another method. I'll comment it off. Wow, I didn't think of this before at the beginning, so it's a waste of time. I hope I can do it in several minutes. Transform to maps and collect the result. Const path map equals new map. For let path of paths, path map, set path 0 to path 1. So now pick any path in the map. Let's say for the first one, right? How can I get the first one? Well, for let any path of path map. We break it. We can get any of the path, any, yeah, and then just recursively reach to the end, right? So while any path, while path map has any past the tail, right? While it has it, we go to the next one. Equals it. Okay, let's see. Let's start equals any path. Next, while start 0, if, okay, start should be this. If path has it, we update the start to path map get start, and then do it over again, and finally we return start. It will end as the last one, right? Let's run the code. I think this should work too. Wow, why I didn't come up with this one at the beginning? It's just a waste of time. Anyway, let's submit. Of course, we accept it. And for this solution, the time would be linear here. This will be linear. So this will be actually linear time. Oh God. Cool. Submit again, and we go to the next one. Back to the contest. We use 45 minutes. Wow, these guys use 20 minutes. Okay. Okay, next one. If check if all ones are at the least length k places away. What the fuck? Given an array nums of 0 and 1s and an integer k, return true if all ones are at least k places away from each other. Otherwise, return false. So for this, example, k is 2. So this distance 3, this distance 2, this distance is 6. They are k away. True. This is an array, right? Yeah. 2, 1, k, 2, false. At least k. For these, k 0. And for these, 0, 1, k, it's true. There are a lot of numbers, right? So we should do it in a linear time. K, okay. So I don't know why the distance of the third one, this one with this one will be pointing it out, because it must be distance plus this bigger than this 2. So if any of these two fails, it fails. If these two satisfy, it will satisfy. So I don't, not why I don't know. It's very simple, looks to me. So we'll just loop through all the elements and keep track of previous one, right? Yeah. And for the first one, we suppose that there is a 1 at the very, very, very far away, which is infinitive. And we calculate, when we met a new one, we calculate the distance between the previous one. Okay. So let prev1 index equals minus infinity. when we met 1, we calculate the distance equals I minus prev 1 index. Don't forget to update the prev 1 index to I. If distance is bigger than, so it's at least k, so it could be equal to k. If it's bigger than k, we return false. For the other cases, we return true. I think this should work, right? Huh? Uh-oh. Oh god, it's my bad, it should be smaller. Well, this is it. Let's try some custom cases. 0. I'm totally lost my confidence. Runtime error? Huh? What the fuck is runtime error? JSON input is not undefined 1. What the fuck? Huh? What the fuck? JSON parse input. Something wrong. I just submit. Wrong answer. What? I want to give up, man. Previous one is this. If it is 1, the distance will be, if it's, so this one is okay, and this one, god, the distance is not purely the subtraction. It should be what? 1, 2, 3, so -1. Cool. Go to next one. Wow, this is a cool. Okay, and next one, longest continuous subarray with absolute diff less than or equal to limit. What? I didn't understand. We're given an array, an integer limit. Return the size of a longest continuous subarray. Okay, such that the absolute difference between any two elements is less than or equal to limit. What? In case there is no subarray satisfying the given condition, return 0. What does this mean? Return the size of longest continuous subarray. Well, when we see continuous, it must be dynamic programming, such that the absolute difference between any two elements is less than or equal to element. For 8, less than 0, less than 4, cool. This does not work. This is does not. If this is already checked, then this is does not work, right? This is does not work anymore. 2, okay. 2, 4, okay. 2, 4, 7. No, not working. 4, 4. So for the sizes, longest is 2. We can only return the account, the count. So actually, this could be deducted, reduced to checking the longest continuous subarray, which ends at each index, right? Let's suppose that we know the longest array in this one. So how we could check that one at this new number? Well, the numbers between them are checked, so we actually just to check this one against each of them, right? Well, and then that's a dynamic programming solution. Well, I'll say cache the result of longest subarray end at index I. So for fi, right? Now fi plus 1 means for the next one, we could just check nums I plus 1 against nums I to nums I minus fi. If there is if there's only one, we minus it and plus it, plus 1, right? Yeah, so that's the solution. Cool. Let's do let's use the cache, I think, which means longest length end at, which we'll just use array, and for let, do we need the index? Yeah, let I equals 0 I smaller than nums.length nums. So for the first one, we only check if itself is bigger or not. So if I equals 0, we set it to nums I smaller or equal, right? The less than or equal. So smaller than limit. If it is, we set it 1. If not, it's 0. Right? And for the other cases, we will get the previous one. Proof equals next k equals proof. We handle it by, if it is 1, then it's itself. So this is start from 1, and yeah, it should be bigger than 0. Okay, minus minus. Let new length equals no, I'll just say if we found any number that has bigger diff, if nums I absolute value, right? This is negative or positive? It's positive. Cool. If this minus, we use math ABS, nums I minus 1 minus k. Oh, sorry. I said 1 pref. Sorry, 1 0. It's okay. So for if there is 1, the k will stop at 0. So this will be working. This is working. If smaller, it's bigger than k. If it's bigger than k, we'll set it to 0 and break, right? If it is not bigger than k, if all is okay, we just set it to the previous one, +1, right? Got this. If okay, if I want I +1. If not, 0. And finally, we return, oh, we forgot to update the maximum. So let max 0. Every time we say something, we need to update it. So wait, we break here. If break is 0, so we don't need to check. For the other cases, we can say math max longest I. And finally, we return max. Let's run the code. Oh, not a number. What? God. Not k, man. It should be limit. Why we? And still not a number. What? We're getting the result like input like this. Okay, we traverse through all the numbers, and I for the first one, we check against the limit. Okay, this is working. So prev is I-1 is cool, and then for k, for each of the previous array, we check it against nums I. For k0, it's I-1 itself. So if it is bigger than limit, then this should be set to 0. Yeah, and break, right? Yeah. If not breaking, if not breaked, we set it +1. Oh shit. Sorry, I should this +1. Okay. Still 3. What? It should be 4. Huh? Oh, we're right. Okay, submit. Hope it works. Wrong answer. How could it? I want to give up. The idea is on the right path, I think. Output 3, expected 2. Why we get 3? This is 5, right? Let's log. God. Let's console log. What's the problem? I said that we get if long is 0. Ah, I made a mistake. If this is 0, we plus it to 1. You see? If the previous one is 1, we'll check it. But okay, there's another if clause here. if prev equals 0, there's nothing to do, right? Its maximum should be 1. Ah, God. So there here it would be more details around the code. No, it's not a 1. Oh, gosh, shit. It should be like this, man. If for this case, you see these two are the same, so I can remove the 0 case. Proof is like this, or default to 0. So if previous was 0, we check if the limit, if it's 1, it's 0. So if the previous has some numbers, we loop through all the checks, and if they are bigger than it, so we will break. Oh, we should not break. It might contain itself, right? So we will do this again and break. Cool. This time it should work, man. Still 3. Console log the. I want to give up. I want to give up. 0, 1, 2, 3. What? 0, 1, 2. Why we get 3? Itself must be. Itself must be also be checked. God, itself must be checked. Okay. For the other case, first check itself. If nums I is bigger than limit, should be 0. If it's smaller than it, we will do like this. No, there's still something wrong here. There should be two. God. First, we need to check itself, determine the minimum, right? So const self equals nums I plus it's okay, then it's 1 or it's 0. If prev is not 0, we will do the check. It's like this. If previous one, if self is bigger than 0 and prev is also then bigger than 0, then we return check if we could concatenate any numbers. So we loop through the prev one and find that there's something wrong here. Actually, the conditions does not work. The logic here. I mean, like for we get the longest will be like 3. So if we add a new number, if it's bigger itself is more than 4. So what do we do? This might is more than 4. And this might not be, right? But we're checking that ending at. So the condition actually seems more complicated than I think. We are getting the longest subarray ending at each index. Like here, I mean these 3 are all possible the outcome. So when we add in a 7 itself, it's not available. Okay, we're gone. We get a 2. Okay, if we get another number, it is valid, then we might fail at some point, right? But when we failed, the rest numbers are all actually valid. So, oh, I see. So when we are traversed through 0 to previous, okay, plus 1. If we find anything that is bigger than limit, then we should say prev let current. We should set current equals to what? Equals to actually plus equal to what? Equal to k is 0. When k fails at 0, plus k, right? If we fail at the second number, which means the first number is okay to go. Yeah, so plus k. And now finally, we set the current. And this to max. Oh, now it becomes 1. What the fuck? 0, 1, and for 4 it should be 2, but and the previous one is 1. Current is 1 because current is 1, and the previous one is bigger than 1, bigger than 0. So we loop through k will only add 0. Ah, God, we should k because k will small. Yeah. Ah, I'm so bad at the boundary. Huh? Ah, it's not like this. It's not. Okay, we check it. I think we should do something like this. +1 for the first one. If not, it's okay. Ah, shit. Submit. Uh-oh. Seems like TLE. We only have like 20 minutes to go. Ah, why? Okay. Why we? Uh, I really want to die. Wow, this one seems much more complicated than I thought. Okay, 0. Why it's 0? Hmm? Hmm? The input is 0, right? The limit is 0. Ah! I made a mistake. It means the maximum is diff. It will not check itself. My man. Oh God, man. Xa. It means any one number will be valid. Shit. Anyone will be valid. That if that's the case. Wow. Shit. I didn't read the problem carefully. Okay, we start with 1. Prev will not be 0. And current, it's there's no need to. Current was 1. Okay, we place it to 1. Longest. Ah, so sad, so sad. Uh-oh. Still not right. Oh, sad, sad. This is so sad. This is so sad. 10. Why we output 0? Mm-hmm. Current, right? Oh, max is still 0. Oh, 1. Oh my God. Still not right. Oh God, this uh, if I can tackle this one, I think I'm ready to go home. So for this one, okay, expected 3, but we out to 4. Huh? Ah, this one. Run the code. Okay, we out 4. So here 1, 2, and this one is 3, and this is, so we failed at here, so it should be 2. Uh-oh. Oh. So proof, like for here, proof means there are 3 numbers. When we are traversing through it, and we check it, and the k actually it means we traverse through k0. Previous one would be 3, so k would be 0, so 0, 1, 2. 0, it's okay, we plus it, so 2, and then 1, it's not, so we break, the current actually will be 2. Max, shit. Oh my god. I wanna die. Remove the console. Uh-oh, TLE. God. The console caused the TLE, so okay, accepted. Let's go back to our I forgot to analyze the time and space complexity. For time, we traverse through all the numbers and go back to, so for the worst case, I think, for the worst, it's n squared. Because you see for the loop here, the worst case will go back to the original point 0. Space, we use linear, use array to keep track of the result. Medium, okay. We still have 10 minutes. See if we could tackle all of them. Find the kth smallest sum of matrix with the sorted rows. We're given n by n matrix, mat, and integer, which has its row sorted in a non-decreasing order. Non-decreasing order. Rows. Non-decreasing, like this, ascending. Non-descending, so there might be same numbers. I'm allowed to choose exactly one element from each row to form an array. Return the kth smallest array sum among all possible arrays. This, so 5, this first one is this, right? And then go to 1, 4, 3, 1, 3, 2. Why we go to 1, 4? Because 2 is smaller than 3, right? 1, 4, and then we got 1, 4, and 3 would be smaller than 6, so we got 3, 2. Oh, wait a minute. 1, 2, and then 2 is smaller than 3, so 1, 4, and then 3, 2. And then 3, 4. And 1, 6. all possible array, and how we can do this cleverly. M and N matrix. Suppose we're getting the fourth, and then how we can get the fifth? We've already go to 3, 4. 3, 2 is, if we go to 3, 4, which means 3, 2 is checked, 3, 4 is checked, and 2, 1 is checked. 1, 4 is checked. I think that we could maintain the last position of matching for each one, right? For the second array, we say we already checked 1 for each number. For 4, we checked 1, but maybe for 6 but 4 we checked 3, but 6 we only checked for 1. So actually, what we could do is use 2 pointers and go through each of the number. Let's analyze the input like this. So for each one, the first one, of course, will be 1 and 2. So I say for 1, the first number of the next array is checked. For 2, the one 0. Okay, the index 0 is checked. And now what we do, because 1 is already there, we cannot do it. We must move to the next one. So which one? 3 to 2 is 5, and this to 1 is also 5. So either of them is okay. Just to choose 4. So 4 for 0 is checked. Now, how do we move? We could still check for 1. It will goes to we could choose for 3, or still 2, 1, 2, 3, 2, 1. Okay, 2, 1, and then 3, 2, or 4, 1. So or 4, 2, or 3, 2. 3, 2 is checked. So 3 for 0 is checked, and still they are not big enough. So we could move to 3, 3, 4, right? Because they're same. So we're 3, 4, and 4, 3 is also checked. So now let's move to the next one, right? Or 3, 6, of course, it's 1, or 11, 2. Of course, this is 0, and then we could go to 6, 3, or 11, 2. So actually we can do this, but I don't have time. I cannot solve this by, or could I? Or could I? Cool, let I equals 0, let j equals 0, let j for I equals 0, let I for j equals 0. Let's count equals 0. 4. While I is smaller than it's n grid. Oh, we're given a grid. That's hard. Wow. Oh, I give up. Okay, I'll give up. Let's see my submissions of this context. I'm ranking like 3,000. Yeah, you see this one is very incorrect attempts. It's very not cool. Wow, many of them are not participating. Time. Wow, these guys are so they're so clever. I didn't use 2 hours. Oh, I plus the penalty time. God. Wow, someone is okay. What is penalty time? Penalty. Penalty time. Oh, for each wrong submission plus 5 minutes, and they were judging the rankings according to the penalties, judging the ranking by the time. For this time, I think. So I just do a brief recap on this context. I think I've done better than last time. The first one cost me a lot of time because I didn't realize that we could do it very easily. I used a very naive map solution, and then I found that I could do it simply with the array manipulation, and then I can improve it to linear time. So, wow, I think this is clever, but it cost me almost 40 minutes. And the next one is this. This is very easy, but I didn't make it once as -1 here. And the third one cost me more bugs because I didn't read the problem very well and understand it. I didn't understand I made a mistake of how I should implement it. But the idea is the same, I think. So this one is a typical dynamic problem. And yeah, don't read the description carefully. Okay, so back to my context. The contest has ended. Okay, I think I'll create several studios or several videos of each of the problem. Cool. So that's all for this for today. Hope to see you soon. Bye bye.